Trinomial just means, yeah, three things. Three things, three like 2 plus signs, basically. Three things being added that are distinct, that have distinct degrees, like distinct exponents. So one thing you can write, for sure, is you can include 8x squared y cubed. Does anyone want to just make another random term? The only thing is it has to be a multiple of 8x squared y cubed, and it has to have either one more x or one more y, or some amount extra x and y. And you could have another number in front. It doesn't need to be 8. It could be 16, 24. Nice. Okay, so let's do 16, but we want to still have at least 2 x's and at least 3 y's because it's a common factor. So we can do 16. Nice, Allison, we're perfect. So that Allison, what a good example. You don't want to overshoot though. If you make your exponents too large, like x to the 4th, y to the 9th, it will violate the degree 7 condition. So if you just do this, like x cubed y cubed, that one works. Because the degree is 6, and x squared divides into x cubed, y cubed divides into y cubed, and 8 divides into 16. And then the last thing you can do is maybe like another 16 x cubed y to the 4th. This is just one possible example. And this would be a trinomial. Okay. Any questions? I think I just had one example. Any other questions on 70 on this one, 5.179? Okay, let's take a look at 5.2, number 7. So this is 5.2. So assume the following. This is a really nice exercise. X squared plus bx plus c can be factored as x plus q, so x plus p, times x plus q. For these types of expressions, it's important, even though b, p, and q are letters, it's important to actually, and c also, it's important to think of them more as constants, like numbers, and think of x as the variable. And b, c, p, and q are like your coefficients. Or they're like, yeah, they're numbers that are not changing. And that helps me to think about these types of problems. Let's complete the following sentence. This is number 7. If p is negative, and q is negative, then p must be blank and c is blank. All right. Anyone? Can anyone volunteer? Raise their hand using one of the buttons and tell us what if p and q are negative. What do we know about b? What does b have to be?
If P and Q are negative, then that means that B has to be negative too.
Exactly, right? Because if you FOIL this out, very nice. Was that who was that?
Mason?
Mason, nice, awesome, thanks, Mason. Yeah, if you FOIL this out, like your experience, like if it's x minus 3 plus x minus 4, you know that the middle is going to be x minus 7. But you can also FOIL this out in this very useful pattern. You get x squared plus p plus q times x plus pq. So what you find that if the two numbers in the middle are negative, the two numbers in the factorization are negative, then the middle coefficient is also negative. And then how about, Mason, how about C? What does that tell us about C?
That tells us that C is positive because if you multiply two negatives together, that means you get a positive.
Perfect, perfect. Thank you. So, and there's one other comment that's kind of nice to know, is if somebody ever tells you that the roots of a quadratic, or this is a parabola, so the roots, if the roots of a quadratic, let me think about this. With uh, leading coefficient a equal to 1, so this is like 1x squared. The roots of a quadratic with leading coefficient a equal to 1 are, I'm just going to say leading coefficient equal to 1. I want to use them, are a and b. Then um, uh, then the polynomial, or the quadratic, can be written as y equals x minus a times x minus b. So similar to, or let me change it up to q. So it's very similar to what we just discussed, but if you're given the roots p and q, and remember uh, roots, the word roots means when the quadratic is equal to 0. So this is the solution. This is a fancy word for roots. Just means 0 or solution. So if you want to solve this equation, then what you find is that you expand this out, you get x squared minus px minus qx plus pq, and you get this nice fact that's like this. So what that tells you is that the middle term of a quadratic is the negative of the sum of the solutions, sum of the roots. This is negative of the sum of the roots, and this term is the product of the roots. Literally, this is not saying anything interesting. All this is a restatement of the X method, where you try to always come up with, whenever you're solving a quadratic, you guys know that you always try to solve for two numbers that multiply to the last number and two numbers that add up to the middle number. And then to find the answer, you actually make them both, you plug into the negative. So if you think about this, this statement is just saying that just another way of saying the X method. All right, let's try the next problem, which is 5.273. This is nice. So this one's a little bit one of the more challenging ones. This one said, find all integers b for which a squared plus ba minus 50 can be factored. Okay. Anyone? Oh, sorry. What was the second part of the two statements I just wrote down? These ones?
Yeah, I just needed to see the product of the roots part.
Yeah. So this is just like a nice thing that if you ever have and we'll talk about this later. This is not something that's major importance right now. But if I ever write down an equation like this, x squared plus 7x plus 12, then I know that 7, the roots are, you guys know what the roots are here? What are the solutions to this equation? The roots to this equation are roots just means a solution. They're not 3 and 4 there. Those are the kind of x plus 3, x plus 4, but the roots would be negative 3 and 4. So that's what actually makes it 0. So roots are negative 3 and negative 4. And so the sum of the roots, the negative sum of the roots is going to be 7. So 7 equals the negative sum of negative 3 plus negative 4. And the product of the roots is the last number. So 12 equals negative 3 times negative 4. So that's all the statement is saying. It's not super interesting, but it's useful to know if you ever see that, like, oh, what's the product of the roots? What's the sum of the roots? Sometimes you can just get it by looking at the quadratic in standard form. Okay, so let's apply some of that thinking to this one. Find all integers for b for which a squared plus ba minus 50 can be factored. What do you guys think are some possibilities, and how do we approach it? Any volunteers?
I did the X method a few times, so I just put negative 50 at the top and then
Nice.
tried a few different numbers, and I got 3 different numbers.
Nice, Lily, perfect. What's one example?
50 and 1. So
I like that.
negative 1 and 50.
Nice. Okay, so and then if we did that, what would b be equal to?
It would be equal to 49.
Nice. You could also do negative 1 and negative 50 and positive 1 as well. That would be negative 49. Basically, any number you do, you can always move the minus sign and it will work. Sweet. Well done. Is there another pair? Anyone have any other pair of factors that multiply to negative 50?
5 and 10.
Perfect. Yeah, and you can put the negative on either one. So this would be, in the x method, would be b equals, this would be values for b. So b could equal to negative 5 plus or minus negative 5. So let's keep track of these. Plus or minus 49, plus or minus 5. And so we got negative 1, 50, 1 and 55 and 10. And is there one more that's also useful?
25 and 5.
Nice. Oh, yeah, 25 and 2. 25 and 2. So 25 and 2. So we can do, let's say, minus 2. That would be plus or minus. The last value would be plus or minus 12. Excellent. So there's 6 different possibilities for B that can factor. And I like these problems that kind of make you force you to think about the X method and factor. Okay, let's try 85. So but these problems that relate to the geometry are nice because you know
Can you
they
scroll
show.
up real quick? My bad.
Yeah,
Just
yeah, of course. This picture with like a rectangle and then 2 semicircles. And we want to highlight. We're highlighting this area. All right. And they tell us that a few things are x here. So they tell us that the radius of the semicircle is x, the width of the rectangle is x, and the radius of the other semicircle is x. So, what would be a nice polynomial that would represent the shaded area? Anyone have any thoughts? And we can break it up into different pieces and put them all together later. Anyone have any thoughts? Or maybe I'll call on some people. And let's see here. Yeah, and if you don't want me to call on you, oh yes. Okay. The question is, can you express the area? Express the area as a um, some sort of algebraic expression, so as a polynomial. So express the area as a polynomial. So try to work on this on your own for a minute, and then message me when you got the answer, you think you got the answer, and also message me if you're just stuck. You have no idea what to do here. Okay, so those of you who are stuck, first, good, okay. Archer asked a really good question. Does anyone remember before? Yeah, Amy, this is a problem I think from the homework. Um, does anyone remember the equation for the area of a circle? Anyone remember the area of the circle equation? Nice, Allison. Yes. Close, Archer. It's oh, not Allison. A little bit off. It's pi area equals pi r squared. And so please write these formulas down. We'll talk a little bit about why it's true later on, but for now, just you are expected to know this formula. And how about for the circumference of a circle? Does anyone know that one? Nice, Manny. Circumference. How about what's the difference between the circumference? Circumference equals, nice, there you go, 2 pi r. Sometimes also people write, because 2r is the diameter, they also write equals to pi times the diameter. But we'll just stick with 2 pi. Okay, great. All right. Now that you know that, how many, what fraction of the circle do we have overall? We're going to just kind of look at the pieces. Here we have a semicircle, right? Semicircle. And then what is this piece on the right? What fraction is that? So this is half, the piece on the left is half. What's the fraction on the right? Instead of a semicircle? Nice, Amy. Yes, it's a quarter circle. It's a 1/4. So therefore, if we put these facts together, this is half the area. This is a quarter of the area. So adding them together, a half plus a fourth, nice, Archer, you got it. It's going to be 3/4. So the circle part contributes 3/4 pi x squared. Okay, now what about the middle rectangle? Can anyone tell me the dimensions of the area of the middle rectangle? What's the height of the middle rectangle? Nice. Allison, very good. Anybody else? You don't mean x squared, but it's even simpler than that. If you just the height of the rectangle, not x squared, but nice. It's just 2x. Do you guys see that? If this is the radius, and then this is x, and then this is x, so therefore this piece is just going to be x plus x, which is 2x. So therefore the area of this piece is going to be 2x times x, which is 2x squared. So adding them all together, you get this 2x squared. And now you see that these are like terms. You can actually combine them, but you can't really do the 3/4 pi, like it doesn't simplify. So you can just leave it as 2 plus 3/4 pi times x squared. Okay. Are there any questions before we move on? This is a nice little problem using algebra to describe like some geometric quantity.
Is that a plus 3/4?
Yes, that's a plus 3/4. Hit thumbs up if you feel comfortable kind of with using the area formula and kind of combining the pieces together. And also hit no if you feel if there's some step that you're shaky on. Just message me as well if there's some step that you're shaky. Oh, we got a few students. Okay, yeah. Those of you who hit no, please just let me know. Where did you feel lost a little bit? So I'm just writing back to a student here. Yeah, so I'm getting those students were a little bit lost. I agree that um, this problem is a little bit weird. It's kind of like what they're asking here. They just give you a weird shape. They gave in the problem they told us in the problem, here's a weird shape. It consists of like a semicircle with a rectangle and then a quarter circle. And then they say, okay, we're just going to give you some pieces of the weird shape. We're going to tell you like the width, the radius of the semicircle, and using those pieces, what is the overall area? So I didn't just come up with a shape out of nowhere. The shape was given to us as the problem, and they just want you to come up with an expression in terms of x for this weird shape. And it's a good skill to kind of be able to use the basic equations for rectangles, triangles, circles, semicircles to figure out some other interesting shapes. All right, let's try 5.397. Ah, good. So let's do an example first, and then we can. So let me move here. So I didn't teach you guys this. You might have seen it before. So we'll go over it now. And in the future, if I ever assign a homework where it looks like the questions are like something we haven't done in the class, I really encourage you to try to read about the section a little bit on your own, because I think it's something that you might be able to get first by just reading some of the book. And reading the examples in the book before lecture is a really, really good way to learn. Okay, so let's just do this example. This is example 1. Let me give you, this is factoring ax squared plus bx plus c, where a, the first term, is not equal to 1. And you guys might have seen there's one really nice method of doing this. But first I'm going to show you a way that I was taught, which is a little bit longer, but I also think it's pretty good. It just basically gets a check. So example 1. Factor bx squared minus 10x minus 8. So the main difference I think you guys can see between this problem and the ones that we did for the practice for the first exam was I didn't ask you any questions that had a number in front of the x squared besides just a 1. And what makes it harder is that the x method here doesn't exactly work because that first number will mess up the middle number. That 3, if we want to get 3x squared, we know that the two numbers in front of our factors in front of the x will have to multiply to 3. And so the x method doesn't quite work as as we usually use it. So the first method is just kind of thinking about possibilities. So I know that whatever numbers I plug in, I'm trying to guess two factors, that will either plus or minus, but when I FOIL this out, I better get 3x squared minus 10x minus 8. So can you guys think of two numbers that I can place in the green spots, in the green blank spots? What are the two numbers that will multiply to 3x squared? What are the,
3 and 1.
3 and 1. And it's really nice when it's a simple prime number in front of the x squared, because there's only one possibility. So 3 and 1. Okay. Now, I don't know what fits in the last two numbers, but what are some possibilities, because it has to multiply to negative 8. So they have to multiply to negative 8. So what are some numbers that multiply to negative 8?
Four and 2.
Nice. And which one do you want to be negative? And we can just do some guess and check. Maybe first negative 4, positive 2. But we can also try 3x plus 4 and 3x minus 2. Is there any other set of factors that might work? Oh, not 3x, sorry. What's another pair of numbers that multiplies to 8?
8 and 1.
8 and 1. Nice. So we can do plus 8, 3x minus 1, 3x minus 8. Oh, I'm sorry, I keep writing 3x. There's not 3x. X plus 1. Okay. And now the name of the game is just to figure out which of these has a middle term, which will be negative 10x. And let's FOIL out the first one. You get 3x squared, and then if you just look at it here, it'll be negative 4x plus 6x, so that's going to be plus 2x. And the last number will be negative 8. So all of these will have the same 3x squared. This will be plus 4x minus 6x. This will be negative 2x minus 8. Let's see here, 4. And 3x squared. Oh, also, yes, there is one other thing. Yeah, so we're noticing that is there another arrangement that I can do as well? So let me move these. Does anyone see another possibility I can do? So I did the different places of negative 4 and 2, but what else is important for me to consider? So where you put the negative 4 and the 2 is important, because if you put it with the 1x, it gives you a different expression when you FOIL it out. So I also have to consider swapping the 3x and like where the 2 and negative 4 are. So I can do plus 2 times x minus 4. And then I can also do 3x 3x minus 2 times x plus 4. Three x, yeah, so 10. minus 6x. Is there something wrong here? No. Ah, yeah, so it's going to be this one. So we do 3x squared, and then you have 2x minus 12x. So that gives you minus 10x minus 8. And that's the one that works out. And this one, you don't have to keep doing it, but this one underneath will be 3x squared, 12x. This would be plus 10x. Okay. So this approach, where you just kind of list out all the possible factors and see which one works, it's quite time-consuming. It is nice to kind of like you're just doing guess and check and seeing which one will work out. And just remember that the number with the that doesn't have a 1, you have to be really careful, like to make sure you FOIL properly. This is one approach. How many of you have seen this approach before? Just kind of using the first coefficient to guess like what's going to be in front of the x's, and then nice, a few people have done that before. Have any of you ever seen another approach? Anyone want to have heard of another approach? There's one other approach that's really nice. And I actually wasn't taught this approach in high school. I don't know why. It's almost like cheating. This way of doing it is really kind of long. Have you guys ever heard of the slip and slide method? No? Okay, cool. Well, so let me show you, and it will help a lot with these problems. So slip and slide method is just the method. There's no like we're not solving some equation or anything like that. So the intermediate steps that we're writing down are not equations. We're just kind of we're doing some manipulations, and it just happens to work. And you can think about why it happens to work. It's a very nice approach. So let's do the same problem, but we're going to do it by converting it to a problem where we can do the x method. And I'm not going to say we're completely getting rid of guess and check, because you guys realize that the x method is really just a very comfortable way for us to guess and check. We're just used to it. But that's all it is. Okay. So the slip and slide method the slip and slide method says take the 3 and multiply it by the 8 to get a new quadratic that will be nicer to factor. So you get x squared minus 10x minus 24. How does x squared minus 10x minus 24 factor? What are the two factors of x squared minus 10x minus 24?
Negative 12, too.
Nice. So you get x minus 12 times x plus 2. Right. And now this is where you can have some freedom what to do, and usually you're going to choose. So what you do here is you pick one coefficient to get the a, and one number to. So let's say I pick this one to divide by the a, and I'd pick this one to divide. So divide by 3 here, and divide by 3 here, and then multiply by 3 over here. Okay. So what you get here is a new equation, and this is not a, again, these are not, this is just a way to manipulate things to get the answer. It's just like a tool. You get 3x plus 2 times x minus 4. You could also have done something else. I think you could also do, if you want to do make the other one 3x, you can do that. Then you have to just divide the 2 by 3. I think that, let me see, would that work? So multiply that one by 3. Yeah, that would also work. So, but usually we pick the one to divide by one of the numbers will be nice to divide. So let's try it with another example that they give us. So yeah, so here they are dividing a few of them. Let's try this one. So this is try on your own. 6. Try this one. So try to factor. Factor 6x squared minus 19x plus 10. And they do this in the book, and you see that it's actually going to be quite annoying, because the 6x squared is even more annoying than the 3x, because it could be, it's not just 3 and 1, but it could be 6. The possible factors for 6 could be, you can have 2x and 3x, or you could also have 1x and 6x. So there's a few different cases to consider. So doing it the way that I first showed you could be very tedious. It's doable, but it's tedious. And sometimes you can make smart guesses based on the negative 19x. But see if you can spend a few minutes to try the slip and slide method on this one. And message me if you need some help, or once you got it. I'm just gonna cut it and move it over. And I've made a comment on several of your exams. When you're doing math, make sure when you write equations that everything is true. Like the left side equals the right side. And then if you do another step where you change something in the equation, if you did something to like alter the equation a little bit to like go to the next step, don't just write equals after what you just wrote. Make a new line or draw an arrow. So that's really important. I'm drawing an arrow here because I know that these things are not equal. Now these equations are not the same. These are not the same equations. So I can't just write an equals there. But I can draw an arrow. These are equal. These two are equal. Then when I go back, I do know that these are equal. Any questions on how I what the method is here for the dividing by that number, that leading coefficient, and multiplying? You just have to pick one of the numbers that's easy that divides by your leading coefficient, and the other variable will have it. And you can always, there's one thing you're allowed to do. If you see that you have a fraction in one of your expressions and you have a common factor in the other one, you're actually allowed to move the number from one expression to the other. Excellent, nice. So those of you who messaged me the answer, do you see that one of the terms, a number can be factored out? Well, let's try this out. So if you wanted to slip and slide here, this would draw an arrow. This would be lead us to do x squared minus 19x plus 60, which we know factors because negative 19, the two numbers that multiply 60 that add up to negative 19 are x minus 4 and x minus 15. And now here it gets a little bit interesting. There's no number, 4 and 15 don't divide into 6. So you could do this. This is definitely okay to do. You could do, you could try to go back. And say this would get you to 6x minus 4. So maybe I put times 6 here. So I can do, the orange will be times 6. The purple will be divide by 6. Times 6. So yeah, 6x minus 4 times x minus 3 halves, so 2.5. And this is okay, but sorry, not 5 halves. This is okay, but you might not like that that there's a fraction showing up there. So if you want to try to get rid of the fraction, you can notice that on the left factor there's a 2 in both of the terms. So you can do 3x minus 2, take out a 2, and then bring that 2 inside the other one. That would give you 2x minus 5. So both of these are totally okay. They're both factors. They just look a little bit different. Just the fact that the 2 moved from one of them to the other. And you could have done something, instead of dividing like by 6, you can actually break up, you can do dividing by 3 and multiplying, like dividing by 3 and 2 on separate pieces as well at once. But I'd rather just readjust it. All right. And then if you double check, if you FOIL this out, you get negative 4 minus 15, and it adds up to negative 19. So it's really nice because you don't have to guess and check. You don't have to like list out a bunch of possible cases. How do you guys feel about the slip and slide method? Are there any questions on it? Any questions on this example? Yes, if you're comfortable with kind of what I did, just with the method itself. And if it seems easier than just doing like a lot of different possibilities. And hit no if there's some part of the method or some part of the last problem that you're a little bit stumped on. Okay. So the last, let's maybe take just like a 3-4 minute break. You guys have been doing these problems for a little while. Take a few minute break. I'm going to look something up, and then let's say in 4 minutes, like 3:03, I want to start going over some stuff about equations of lines, systems of equations. And I'll be here if anyone has any questions, but grab a cup of water. And if you have any questions about any of these examples, now is also a great time to ask. Oh, there's one. All right, guys, welcome back. So just give me a thumbs up if you're ready to, you got your notebook out, you're ready to keep going? Awesome. Okay, great. So let's continue. So now we're going to move on to Chapter 8, Systems of Equations. The main type of thing that we'll try to apply, or we'll see systems of equations pop up, is word problems. Word problems with two unknowns. Two unknowns and two kind of conditions. For example, uh, if we're given, this is just a basic example, if at the movie theater we know that so they charge $5 for popcorn and $3 for soda, and it in total brought in let's say $19 for selling 5 items. How many of each did they sell? And we're going to do a bunch of problems like this. So the first thing that we always want to do, and this is something I'm always going to emphasize, is clearly define variables. And these types of problems is where it's most important to do this. So can anyone tell me what are some good possible variables and what they should represent? What is unknown? There's 2 unknowns here. What are they? Excellent. So P could be the number of popcorns bought. And this is really important. A lot of times students, they'll just write like P equals 5 because they see popcorn sells for $5 and they'll just write P equals 5. But that's actually known. We know the cost of popcorn. So define your variables. P is the number of popcorn sold. And S could be the number of sodas sold. And I want you, every time you do one of these, to actually write a little phrase. Never just write one word like P equals popcorn. Always write number of popcorn versus like, because you might get it confused with the price of popcorn. So always use a phrase here. This will be a requirement for getting full credit. So use a phrase to avoid confusion. Okay, now what are the conditions that we are given? I see Amy, excellent. So Amy wrote that the total amount of money that they got was $19, right? So the total money, the term is total revenue. Revenue is what a business takes in before you take into account the cost. So it's just like the total take of a business. The total revenue, which is equal to $19, well, if you sold P popcorn, do you guys agree that it's going to be, each one is contributing $5, so it's 5P plus 3S. So we're just writing up an equation here. And what's another equation that we can write down that would represent the total quantity? It's a really simple equation to represent the total quantity. How many items do we sell in general?
19 equals 8x or something.
Well, P and S are not, they're not like variables because one is the number of popcorn, one is the number of sodas. So we can't do anything to simplify this. But what equation could we write to represent the total number of items that was sold? We haven't used that information yet.
Isn't it just wait, hold on. Isn't it just 5 equals S plus P?
Exactly. And I'm going to write P plus S, but that's the same thing. Okay? And we're going to do, nice man. We're going to do a bunch of these types of problems, and you'll learn how to set them up. Like once you see it, you'll learn, okay, this is this type of problem, I can set it up. And you won't, I'll try not to memorize like, try not to memorize each step. You'll just kind of, after experience, you'll start to see a really common strategy for all of them. Okay, so this is what we call a 2 equations and 2 unknowns type of problem. Oh, guys, oh, sorry guys, I'll be back in 1 second. Hey guys, I have to run to the hospital, but I will just kind of encourage you guys to read some 8.1, and we're going to go over next time solving a pair of equations with 2 unknowns by using elimination and substitution. So how to solve using elimination and substitution. And we'll talk about that tomorrow. All right, guys. I'll see you guys tomorrow, okay? Sorry for cutting it short.
Thank you.
Okay. See you guys. Bye.